Let's do a problem. Here, a picture shows an aircraft just before it touches the runway. When the aircraft was 3.5 kilometers away from the airport, it was at a height of 315 meters above the ground. So, here in the schematic diagram, we can see that when the aircraft was 3.5 kilometers away from the airport, that means this distance was 3.5 kilometers. The aircraft was at a height of 315 meters. So this height is 315 meters. We have to show that flight could land at the airport safely if it reaches a height of 180 meters when its horizontal distance from the airport is 2 kilometers. So landing safely means that aircraft touches the ground on the runway. And the orange line here shown in the schematic diagram is the runway. So we have to show here that while coming down, if the aircraft is at a height of 180 meters, when its distance from the point of touchdown on the runway is 2 kilometers, if this is the case, then the aircraft would be able to land safely at the runway. Mathematically, we can say for safe landing, when the height of the aeroplane becomes 0, that means when it touches the ground, then the horizontal distance of the aircraft from the runway should also become 0 at that point. So that means the point of touchdown here should be 0, 0. Height becomes 0 and horizontal distance from the point of touchdown on the runway also becomes 0. Let's understand the approach for solving this question. Important point to look out for here is that path of descent of the aircraft is a straight line. That means height and the horizontal distance will follow a linear relationship. That would imply for height and horizontal distance, we can form a linear equation. And using that equation, we can show that when the height of the aeroplane becomes 0, its horizontal distance from the runway also becomes 0, thus meaning a safe landing. Based on this approach, let's solve this question. So let's try to form a linear equation y is equal to mx plus c, where y represents height and x represents horizontal distance. Solution pairs for this linear equation can be 3500, converting 3.5 km into meters, the horizontal distance, and 315 meters the height, and the second solution pair can be 2000 meters, converting this 2 km into meters, and height here is 180 meters, so here we are having 180. First we'll put this solution pair in y is equal to mx plus c, so that will be, in place of y we'll write 315, so 315 is equal to m into x, x here is 3500 plus c. We can call this as equation 1. Then we'll put the second solution pair. Here y is 180, so in place of y we will write 180 is equal to m into x. Here x is 2000 plus c. Call this as second. Solving for m and c, we will have m is equal to, it will come as 9 by 100 and c will come as 0. Therefore, required linear equation is y is equal to, in place of m we can write 9 by 100 x. This implies 100y is equal to 9x, this implies 9x minus 100y is equal to 0. For safe landing, when height becomes 0, that means when y is equal to 0, then horizontal distance from the runway should also become 0. Let's see if this happens or not. In this equation, let's put y is equal to 0. So when we put y is equal to 0 here, the equation becomes 9x minus 100 multiplied by 0 is equal to 0. This implies 9x is equal to 0. This implies x is equal to 0. So indeed, when y is equal to 0 is put in this equation, x also comes out equal to 0, therefore meaning the aircraft will have a safe landing. So here we have proved if the aircraft is at a height of 180 meters, when the horizontal distance is 2 kilometers, it will have a safe landing. Let's summarize what we have learnt in this problem. We understood the variables involved and their relationship in a real-life context is the key to form a linear equation in those variables.